This game was recorded live. And yes, those are live decoded transactions on base, which can handle 10,000 TPS. That's roughly 100 milliseconds per transaction. The very moment the block on base reaches consensus, the transactions are processed and streamed to the game. We're able to surface this data on-chain state in real time thanks to the wallet activity GoldRush streaming endpoint running on Covalent's new sub-second data coprocessor. There is another trading-focused GoldRush streaming endpoint for real-time updates on the open, high, low, close, price, and volume tokens at configurable intervals, and even a GoldRush streaming API for token balances capable of fetching sub-block pre-confirmations from base's blisteringly fast Flashblocks. Here's what's going on under the hood. Each time the player picks up an item in the game, a transaction is sent to the base chain. That transaction is immediately picked up, parsed, and interpreted and streamed in milliseconds. No polling, no cache, delays, no stale data, just live verifiable blockchain state, visible in-game as it appears. Now here's the core problem we're solving. Ultra-fast chains like Base, MegaETH, and Sonic have optimized block production and confirmation times, 100, 400 millisecond block times in some cases. But the rest of the stack, indexers, subgraphs, RPC nodes, even explorers, are still operating on 3 to 10 seconds scale latency. That means the user experience, especially for real-time apps like high-frequency trading, is often several seconds behind the head block. This is what we call the latency crisis. That's completely unacceptable for on-chain games, real-time agents, financial monitoring, and anything else interactive. Covalent's new sub-second data coprocessor is effectively a specialized compute unit alongside the core node infra. It semantically pre-processes hot data like relevant contract state and streams filtered on-chain activity through a low-latency pipe that can be consumed via WebSocket. Unlike traditional indexers that operate on fixed polling intervals, the data coprocessor captures all transaction activity, filters it based on contract and function definitions, and streams structured ultra-fast updates tied to canonical on-chain state. Every update is cryptographically tied to the chain's canonical state, so you're not just trading latency for integrity, it's still verifiable. The racing game you're watching now is just a demo, but the architecture applies to anything. Anonymous agents, compliance monitoring systems, high-frequency tradings, agentic frameworks, and yes, actual on-chain games or interactive UX. It lets players and apps speedrun the chain. You can try this demo yourself or start integrating the data coprocessor with just a few lines of code at covalenthq.com.